A sample of an unknown radioactive isotope initially weighs 5 grams, and 1 year later the mass is decreased to 4.27 grams. So how quickly is the mass of the isotope decreasing at that time, and what is the half-life of the isotope? So this is an exponential decay problem. So we can start with the exponential decay equation, or we can start with the differential equation. So I'm just going to start with the differential equation. So we have the change in the mass over the change in the time is equal to K times the mass. So the exponential decay is such that the change in the mass is proportional to the mass. So the bigger the mass, the faster it will change. So this is how exponential decay works. And when we anti-differentiate this, we end up with, we separate our variables, we integrate both sides, and we're going to end up with log of m equals kt plus c. And solving this, we're going to have m is equal to e to the kt plus c, and we can rearrange this to, I'm going to use that plus c and make it e to the c. That's our coefficient, and we end up with e to the kt. So this is solving the differential equation. Now, because it is an exponential decay problem, really we could have just gone straight to this point here. Okay, and the exponential decay equation looks like this: m is equal to the starting mass times e to some kt, and we really just need to solve for the initial mass and the k value, the constant term that we found in our differential equation. So we're going to start by solving for m of 0. So at time equals 0, we're going to have it's going to be 5 grams. And we have e to the k times 0. Well, e to the k 0 is 1, so we have our initial mass is going to be 5.00 grams. Okay, so that's what they told us anyways. So really what we need to solve for is the k value. We can solve that by plugging in t is equal to 1. I'm going to end up with 5.0, that's going to be equal to 4.27 grams, and the equation is we solve for the m naught, so that's the initial value, e to the k, which we don't know, and we know that's 1 year. So solving this equation, then we can solve for the k value, so we end up with 4.27 over 5.00 is equal to e to the k. So we end up with a k value is equal to the log of 4.27 over 5.00. And that k value, when we solve that, works out to be negative 0.1578. So I'm just going to round that to 1.58. So that represents our k value. So we can go back to the question here, and it says, how quickly is the mass of the isotope decreasing at that time? So we want to know the rate of change. So we're going to look at this differential equation, and we're going to say that the change in the mass over the change in the time, when the mass is equal to 4.27, is going to be equal to the k value, which we calculated to negative 1.58, times the mass, which is 4.27, and we get the rate of change works out to be negative 0.67, and I'm going to round that to 4 grams per year. Okay, so at 1 year, at t equals 1, which is when the mass is 4.27, we're going to have a rate of change of negative 0.67 grams per year. So that's part A. So part B is asking for what is the half-life of the isotope. So for part B, we really just need to say that whatever our initial mass is, we're just going to take half of it, and we want to know the time that this occurs. So this is our equation, and we really just want to know how long does it take the original mass to become half the mass. Now, when we solve for t here, we can just cancel out these. These are just unknowns. Okay, they just cancel out, and we end up with, we're going to log both sides, so we're going to end up with log 1/2 is equal to negative 0.158t. So I'm just solving that exponential growth equation where the n value is half of the starting value. I could put numbers in there as well. Okay, and then I'm going to solve for that unknown time of t. So t is equal to log 1/2 divided by negative 0.158. And when we plug that into our calculator, that works out to be 4.392 years. Okay, so that's how long it takes for the initial amount to end up being half of that amount. So whatever we start with, you put the initial amount as 5 grams and the half-life amount as 2.5 grams, and you will get the same thing because we're just going to end up with this ratio of 1/2 here.